A very good morning to all of you. So, this is our second class for physics. Yesterday we discussed or basically we'll say that we briefed about physics, what all we are going to see in the upcoming days and also what all you are going to learn throughout in your first year and second year for preparation for NEET. Good morning once again. So, I hope all of you are doing well in your lives. So, here yesterday we were dealing with a bit of what physics is all about. Then we also saw about some technical terms wherein we defined what is called a system, what is inertia, what is force, okay. And we also saw that physics is the study of physical quantities. Okay, I hope again I am audible to all of you. Otherwise, if someone is not able to hear me, that means you need to check the quality of your earphones or headphones, whatever you are using, or be close to your device so you will be able to hear me properly. So my voice is more than sufficient. Okay. So please don't waste your time in writing unnecessary comments, rather than you can focus on the class. Okay. So here yesterday when we saw about physical quantities, I said that physical quantities are anything that can be measured. They are measurable quantities, right? So today we will bifurcate or classify physics in physical quantity again into two parts. One is fundamental and one is derived. Yesterday I talked about physical quantities being scalar and vectors. Two types we saw. There is one more type of classification where we talk about the quantities being fundamental or derived. So when we talk of a physical quantity, so before coming to the two types, we will see first that how physical quantities are represented. So when we talk of the representation of a physical quantity, we can take any physical quantity. Suppose I am calling it as x, capital X. I am giving it a name. It can be anything: force, mass, velocity, acceleration, whatever it can be, energy, work. So here, whatever is the physical quantity x, this can be represented as Nu. The representation of the physical quantity x is Nu. So what does N denote here and what does U denote here? N gives you the magnitude, and this part U denotes what we call as an unit of x. So a unit, not an, a unit of x. And what is this N? N here is magnitude of x in the selected unit. So whichever unit you have selected for x, in that unit, what is the magnitude, which simply means the value of x. So the value is denoted as N and U is called the unit. So if you want to know about a particular unit, so first let's define what is a unit. So can anyone among you tell me just in short or in brief, what do you mean by unit? So unit, if you talk about in English, there are a lot of meanings of unit. Unit also can mean one, but here what is the meaning of unit? When we are expressing any physical quantity as Nu, then what do we mean by unit? So I am waiting for your replies. If just you can brief me about what you know, then we will be continuing. I'm getting answer as unit says measurement. See, for measurement, when you are measuring something, you have a value that you are representing as n, but I am talking of unit. Okay, I am getting small measurement, measurable term. The physical quantity is the measurable thing, right? Single thing or person, mass, the entities used to measure. Okay, good. The entity used, what entity actually it is? A standard quantity. Okay. So basically unit, what is the role of unit? It simply gives meaning, a meaning to a physical quantity. For example, if I ask someone, give me 2 or give me 5, give me 4, you cannot understand. I have 8, you cannot understand. But if I say, give me 4 kg of sugar, okay, or I am having 4 liters of water. So when I am using that kg or liter, then I am giving a meaning to the physical quantity. So someone can understand that I am talking about something called mass, something called volume. When I am using the term kg, then you are coming to know that yes, we are speaking about mass, kg. When we are talking about liters, we are talking about volume. So when you want to give a meaning to a physical quantity and you want to differentiate or distinguish two physical quantities with each other. For example, if I just say that there are two physical quantities of magnitude 4 each, you cannot say which one is what. But if I say that one is 4 meter and one is 4 kg, then you can understand that 4 meter means I am talking about some length. When I am saying 4 kg, I am talking about some mass. So when you are getting the meaning of a physical quantity and you are able to distinguish between two physical quantities, the entity which is used to do so is called as unit. Understood? So this is that entity which gives a meaning to a physical quantity, distinguishes one physical quantity from the other. If you want to distinguish two physical quantities, then we will use what is called as an unit. Those who could not hear me, see, if you are new to using YouTube or typing comments, you all know very well, and those who don't know, for them I will be telling this thing, that there is a very beautiful option that while later you are seeing the video, you can just scroll it and put to that section where we had discussed this thing. You can hear it again and again. No need of writing also right now. If you feel that we are writing fast and you are not able to note it, you can definitely do that later. While you are watching the video again, you can pause that section, you can write it. Okay, and you can hear it also. Those who are clueless that what is going on in the class, we had one class yesterday also, and that video is also available in our channel. You can go there, simply click it, you will be able to access the entire video. So I hope this is clear to all of you. So please don't repeat such things again and again, that please sir again write this, or I am not able to write. No problem. If you are not able to write it, later on when you are watching the video, then you can again just pause it, write it down, then you can move ahead. And whichever section you could not say here properly, or you could not, while the class was going on, you could not listen or understand at that particular moment. So when you will be again hearing that at that particular section, whenever you are free, so that time you will be able to understand it. I hope it is now clear. Let's come back. Okay. So this is the meaning of unit. So if you keep on varying the units, what will happen, that the value of the magnitude of x will keep on changing. So here this class is meant to be in English. So I am very sorry beta, I am not versed in Telugu. So it's better that you understand in English. Everyone over here, I know you all are well educated, everyone knows English. So it is my shortcoming, you can say, that I am not versed in Telugu, I cannot speak Telugu. So I am very sorry for that. So please, here NU. Now let's think about a point, that what happens if I change a particular unit. For the same physical quantity, if I change the unit, what will happen to N? If I change the unit, what will happen to N? So you can understand in this way. Suppose I have 1 kg of rice. If I have 1 kg of rice with me, so what I am talking about? I am talking about mass. So it is mass, 1 kg rice. Now this 1 kg rice is a fixed amount. Suppose I draw it in a diagram. So I can say that, say this is 1 kg rice. Now if suppose I change this kg into grams, so I will say it will become 1000 grams. Now you can see this was the unit earlier and this was the magnitude earlier, 1 kg, and here we are having 1000 grams. So what did you see? You will see that the moment I change the value, unit of mass from kg to gram, the magnitude also changed. So what happens here, that when you change the unit, the magnitude changes, but something does not change. What does not change is the total amount. If you see the total amount, it is fixed. You have this much only. If you make it 1000, all of a sudden it won't happen that the amount of rice in this vessel will increase or decrease. It will remain the same. So what is to be used for every physical quantity, if you are writing NU, so for a given amount, of any physical quantity of x, we will say the product of N and U is constant, N into U is constant, or we can say that magnitude and unit are inversely proportional. Magnitude and unit are inversely proportional. So when we have a given amount of any physical quantity x, then the product of N and U remains constant. That is, N inversely proportional to U. So what sense does it make? It makes a sense that if you can see, I have made kg to grams. Which one is the larger unit out of kg and grams? Out of kg and grams, which one is the larger unit? We know kg is the larger unit. If kg is larger unit, then we can see the magnitude in kg is smaller and in grams the magnitude is larger. Again listen, when I am saying 1 kg is equals to 1000 grams, so kg, if I take it as first unit and if I take gram as unit 2, 1 is the magnitude in unit 1 and 1000 is the magnitude in unit 2. So you can see that since magnitude in unit 2 is greater than magnitude in unit 1, 1000 is greater than 1. So this means we can say that kg will be greater than grams. That means unit of 1 will be greater than unit of 2. If magnitude in second unit is more than magnitude in first unit, this means the first unit is greater than second unit, because I said N and U are inversely proportional. So whichever has more magnitude, the unit will be smaller. This is a very, very important relation for any physical quantity while you are measuring it. I hope it is clear. So N1 U1 equals to N2 U2. We are going to use this particular relation, we can say, for a given amount of any physical quantity if we take two systems of units as U1 and U2. So if I am taking two different units of X as U1 and U2, then I can directly use N1 U1 equals to N2 U2. N1 U1 equals to N2 U2. And larger the unit, larger sorry for the small interruption. I hope now I am audible to all of you. Am I audible now to all of you? Okay, fine. So just in short, I'll repeat where we just stopped before the interruption. N1 U1 equals to N2 U2. I can use it for any system if I have a physical quantity of a given amount. Then if I take two different units U1 and U2 and the magnitude of X in those units are N1 and N2, then I can use N1 U1 equals to N2 U2. And last point I wrote that lesser magnitude greater unit or larger unit lesser magnitude, whichever way you can represent it as, this is to be followed. Clear? Now let's take example of this and let's try to see if we have two units can anyone tell these two units are for which physical quantity? liter and meter cube, these are units of physical quantity called as volume, right? Now the question is, which unit is larger among the two? So we have the first question, which unit will be larger, whether it will be liter or whether it will be meter cube. Yeah, I got that. It is volume. Now we are talking about the larger unit, meter cube. Okay, meter cube is larger. Some are telling liter is larger. Let's see which one. Acha, some are telling it is equal also. Let's see. You should know 1 milliliters. 1 milliliters is equal or equivalent to 1 centimeter cube. This should be known by everyone that 1 milliliter is 1 centimeter cube. These two are always equal. Now, if you write 1 meter cube in centimeter cube, you know 1 meter can be written as 100 centimeter whole cube. So, if you write it is 10 to the power 6 centimeter cube. So 1 meter cube is 10 to the power 6 centimeter cube. Now, if I write 10 to the power 6 as it is, centimeter cube and milliliter are the same. So I will write it is also equals to 10 to the power 6 milliliter, because I said this thing everyone should know, 1 ml is equals to 1 centimeter cube. So 1 meter cube is 10 to the power 6 ml. Now I can further write, if I take 1000 outside, then we are left with 1000 more. But what exactly is 1000 milliliter? It is a liter. So you can see 1 meter cube is equivalent to 1000 liters. Now if I go by the method I said, if I take meter cube as unit 1, 1 is the magnitude in first unit. If I see liters is second unit and 1000 is the magnitude in second unit, that is N2. So you can see again from here, N2 is greater than N1, 1000 is greater than 1. That means U1 is greater than U2. So which one is the larger unit? Meter cube is the larger. This meter cube will be the larger unit. Is it clear to everyone? Okay. Now I'll be giving you a question. Tell me which one you think is more. Which is a greater unit? Mile per hour or meter per second? So at least try mile per hour or meter per second. You don't just randomly reply, think first, then say. It is always a good thing that if we take a pause think then reply instead of suddenly and in a impulsive way we just give our answer. That is never advisable. You always should think first then reply. I hope everybody got the first question. So second one we are talking of mile per hour and meter per second. If we have to compare this, okay, let's quickly check this also. If we see 1 mile per hour, so 1 mile approximately goes for 1.6 kilometers. 1 mile is approx 1.6 kilometer, and hour we can convert in minutes and seconds. So hour, or you can do one more thing, because you all have studied up to class 10. So can I quickly get an answer that 1 kilometer per hour if you convert to meter per second, how much will you write? If you convert 1 kilometer per hour in meter per second, tell me the value fast. I want to hear from you. 1 kilometer per hour, if you want to convert in meter per second, what is the conversion factor? Let me hear this fast. No calculation is needed for this. This is taught up to, I think, up to class 9th in maths it is taught. If I want to convert 1 kilometer per hour into meter per second, then I have to multiply by what? Yes, it is 5 by 18. 1 kilometer per hour is equals to, you write this much. For example, you know 90 kilometer per hour will become 90 into 5 by 18, which is 25 meter per second. This is just an example. This to make you recollect, you all should know this. Fine. So from here you will write this as 1.6 into 5 by 18 meter per second. So this means 1 mile per hour is equals to 16 5s are 80. So 8 by 18, 1.6 into 5 is 8. 8 by 18, which can also be written as 4 by 9 meter per second. Now comes the final part where we have to compare. Again check. This one is unit 1. This one is N1. This one is unit 2. And this one is N2. Now you can clearly see that N1 is less or more. N1 is more than N2. 4 by 9 is less than 1. So since N1 is greater than N2, that means unit wise U2 should be greater than U1. So out of mile per hour and meter per second, U2 means meter per second is the greater unit. That means this will be our correct answer. So some told correctly it is meter per second, not miles per hour. Is it clear? These two examples I hope are clear to all of you. Please let's get a quick response from all of you. These two examples which I took over here to explain which of the two system of units is larger, how you can compare them if you use N1 U1 equals to N2 U2 for any given amount of a physical quantity. This will apply correctly, it will hold correct for any physical quantity. You can use this concept. So this is how we compare two different systems of units. Fine. Now after this, let us now go to what we spoke about in the beginning of this class. I told you about fundamental and derived quantities. physical quantities can also be classified as fundamental and derived. See, whenever we are classifying something into more types, so there are different ways of classification possible. So when we select physical quantities, we can classify them in one form as scalars and vectors, about which we spoke yesterday. Now today we will be classifying physical quantities in two more forms. One is called as fundamental and one is called as derived, and we will see what is the difference between these two and how we can use different units, different systems of units for them. Okay. So we have some interesting stuff over here also for physical quantities can also be classified into number one, we have fundamental. Another name, when you will be dealing with questions later, you will see this word also. These are called fundamental or base quantities. And the second one is derived or secondary quantities. So we have two different types of physical quantities in which we can classify them. So here again, I think those who have joined late, in between I will be telling this thing that if you could not see what was written in the previous slide, once the class is over, when you are free, you can simply access the video again on YouTube. You can pause it to that particular location where you could not see earlier, and then you can pause and write it down. And if anything you could not hear due to some reasons, that point also you can go exactly to that part of the video, you can hear it again, you will be able to understand it. Okay. So this is the best feature of online classes. So presently we are talking of fundamental or base quantities, derived or secondary quantities. Now let's start with what do we mean by fundamental quantities. So when we talk of fundamental quantities, these are those quantities which are having independent existence. This is what we say. Now if I ask you, is mass a fundamental quantity? What will be your reply? If I say, is mass a fundamental quantity? Let me hear from few of you. If I am just telling the statement mass is a fundamental quantity, you are saying yes. Okay. Means you are saying that mass cannot be derived. All of you know F is equals to ma. Can I write m is equals to F by A? If I write m is equals to F by A, then can't I derive mass from this relation? If I know force and acceleration, I can find mass. So that means you can derive mass from force and acceleration in a equation. Not I am saying in practicality or reality. You can derive mass from force and acceleration. Understood? Mass is equals to force by acceleration. It is not apparent mass, it is actual mass I am talking about. Very good. Someone is telling vector division is not defined. Beta, I need to tell you one thing. Kindly see the video, yesterday's video again, so that this confusion gets cleared. Yesterday I told you cannot divide vectors, but you can divide their magnitudes. I have not written F vector by A vector. I have not used arrow. Understood? So I think it is Divya Reddy. So please check the yesterday's video, then you will understand that we can write M is equals to F by A. Now, if I take F and A as fundamental quantities, then I can say that mass is derived from them. It is totally my choice. Totally my choice. If I take force and acceleration as fundamental quantities, then I can take mass as derived quantity. If I take mass and acceleration as fundamental quantity, then I can say that force is derived quantity. If I say force and mass are fundamental quantity, then acceleration will become derived quantity. Yes or no? So acceleration can be derived, or force can be derived, or mass can be derived. I think you did not get my point. I am saying it can be derived. Don't say it is not defined. What I am saying, there is a difference between derived and defined. We are deriving from a formula. When we are saying derived, means deriving from a formula. Understood? It is not defined, it is derived from a formula. And that too, when I am taking force and mass as fundamental quantity, acceleration becomes derived. Mass and acceleration as fundamental, force becomes derived. Force and acceleration as fundamental quantities, mass becomes derived. So what does this mean? Let me make it very clear. It is totally our choice. It is totally our choice that we can select any quantities and tell them as fundamental. Then whatever is derived from them, like in a formula, that will be a derived quantity. But now this creates a lot of confusion. How it creates a confusion? Every person on this planet who knows physics, they can select their own fundamental quantities. Yes, that's what I am telling. Mass is both fundamental and derived until and unless you clarify what type of quantities you are taking as fundamental. You cannot say any quantity in this universe is a fundamental quantity until and unless you have given a clarification of what you are going to take as fundamental quantities. So every person in this world who knows physics, every person who knows physics in this world, they can select their own set of quantities. Now this will result into what? We will have a person to person war just on the basis of fundamental quantities, and there will be chaos all around. So to remove this, people gathered together and they came into a conclusion. Worldwide physicists, they gathered together and said, okay, like in Hindi we have a saying, na tera na mera, hum dono ka, means neither you nor me, let's come to a combined solution which should be accepted worldwide. Then they selected, listen to me carefully first, don't write your comments right now, listen carefully. Then they selected few quantities, they picked up few quantities and then they formed a set or group. That group they considered as internationally accepted fundamental set. And those quantities which are in that group, worldwide we consider them as fundamental quantities. Until and unless stated, you have to take those quantities as the fundamental quantities. But if I talk about is it possible to take other quantities as fundamental or not, my answer is yes. You can select any quantity as fundamental, then you have to create a new set of fundamental quantities. So to avoid any confusion or chaos, what we know throughout the world, we are using the same physics. So we use a same set of quantities which has been given name internationally accepted fundamental quantities. Is it clear now? And in that fundamental set, you would have heard that there is mass, length, time, temperature, current. Do you know that or not? Current, you will see that current, electric current is also taken as a fundamental quantity. Have you heard this? Please let me know first. Have you heard that electric current is also considered a fundamental quantity? Yes, you know this. But do you know electric current is nothing but electric current is actually the flow of charge. Electric current is actually the flow of charge with respect to time, means charge by time. Do you know this thing? So do you know that current does not exist in reality? There is nothing existing called current. It is actually charge present in a body which is flowing from one point to other, and the rate of flow of charge is called time. Is it correct or not? So actually charge is flowing. There is nothing called current. It is just a name given. It is just a name given. What actually flows is charge. So charge is a actual physical quantity which is flowing, say, from this point to this point, and time is an actual physical quantity. Both are actually existing. Current is just a rate, but still charge is not included in fundamental quantities. Current is included. So that explains that it is totally up to people to decide what I want to take as fundamental, what I don't want. So in the internationally accepted set, current is used but not charge. Even though charge exists actually, rate of flow of charge is current. So charge exists, current does not exist actually, but current is taken fundamental. Can anyone tell me the reason that charge exists actually, but why do we take current as fundamental, not charge? But you have included mass. You all have heard, that's why you were replying me that mass is fundamental. So that way the charge should also be fundamental. Why are we not taking charge as fundamental and current as fundamental? What is the reason? Have you ever thought about this? So that's why I told in the beginning that there are some interesting things hidden in physics. Just by telling, "Arey sir, physics is so tough, I am fearing physics, it's just like a demon or ghost," it will not help you in understanding physics. It will make you away. But if you dive deeper, you will feel interest. Yes, I got a correct answer. Basically, suppose it is all about, you have heard that many places it is written in ads, first come first serve basis. I have opened a restaurant and today I am throwing a party, but the party is for 100 people only. First 100 people who come, I will include them in the party, not the other ones. First come first serve. Okay, they are saying current can be measured but charge cannot be measured. Beta, you can measure both. Charge you have heard in coulomb and current is in ampere. Both are measured. So this is not the reason. One student wrote correct answer. I'll tell that fast. So basically, no, charge doesn't depend on factors. Current depends. Let me, please hold your comments. Listen to me carefully. This is the interesting part coming to you soon. I have thrown a party, I have opened a restaurant, I have invited 100 guests, telling that first 100 will be allowed entry. What does that mean? That those who are the first 100s, they will go inside, rest I will keep outside. Same happened here. Charge actually exists, but people got electric shock first. If you go in history, first people got electric shock by touching a conductor and they say, "Arey, something is there." So they named it current. And the reason for current, which is the flow of charge, that charge was discovered later. You would have heard proton, neutron and electron. They were discovered by different scientists like Thomson and Chadwick. They found these all later. So since current was found earlier, discovered earlier, that's why it was given place in the internationally accepted set of physical quantities. Understood? Okay, Gopendra Sinha copying from Google. Please don't copy from Google. Gopendra Sahu, please don't copy anything from Google. I hope it is clear to you. And if you think that I am copying from Google, then let me tell you that if you read from any book in the world, without reading from any book, I don't think that you will be able to understand anything. So what you will say, you have copied from that book. Have you studied multiplication table, ABC and all? What you will say, that yes, I know and I have copied them from some book. We all learn something from books. Google also has copied from a source from where it has also given every information. So please don't copy from anywhere, learn. When you learn something from a place, it is not called copied. copied is something else. And this is not that I am the discoverer or inventor of physics or something. We all are teaching what we have learned, what we have accumulated from different sources. Understood? So please now focus and stop copying or doing whatever you are. So fundamental or base quantities. Now let us come back quickly. So I said here and I clarified here, how do we now define fundamental and derived quantity? So instead of fundamental and derived quantity, we will take a collection or set. So we say fundamental or base quantities, if we consider a collection, or we can call it as a set of two or more quantities, physical quantities. If I make a collection or set, in mathematical word we will use set, collection of two or more physical quantities such that none of them can be completely derived from one or more quantities of that set. So if we consider a collection, or set of two or more physical quantities such that none of them can be completely derived from one or more quantities of that set, then each quantity of this set is a fundamental quantity. Then I will say every quantity of that set will be a fundamental quantity if it cannot be derived from one or more physical quantities of that set only. And once you fundamental set is selected, once you select a fundamental set, all other quantities that can be completely derived from them are, we call them as secondary. So it means that you have to select a set of physical quantities in which none of the quantities can be completely derived using one or more quantities of that particular set. Then each quantity of that set will be called as a fundamental quantity. And once you select a set of fundamental quantities, then every other quantity which can be derived by this set is called as a secondary quantity. Is it clear? This is the most important difference between the two. So we will be stopping our class over here because after this you will be having your next class. So we will be continuing from where we are leaving today. I just told you the definition. Tomorrow you will see in detail that how we can make different sets of fundamental quantities, and then we will talk about the internationally accepted set which I was telling in the beginning, like that charge is not included but current is included. So everything we will be making it crystal clear by tomorrow. Have patience till that, and please from now onwards remember that fundamental or base quantities as such, there are nothing. If you talk about mass being fundamental quantity, I will simply rule it out. Mass is not fundamental, time is not fundamental. It all depends on which set of quantities you have decided to make fundamental. If you make mass, length and time group as fundamental, then you will take them as fundamental quantities, and those they are derived from these will be derived. And if you take force and acceleration as fundamental quantity, then mass will become derived. Understood? So to avoid such confusions, internationally all the physicists, they came to a place and they decide that okay, we don't want a war between person to person, that take my set as fundamental, take my set as fundamental. So better one set, 7 important quantities. We will see that tomorrow. So that will be all for today. I hope you got something from this class. Thanks to all of you.